Hey everybody, Mr. Bergman here. I got a video for you. It's talking about a common question. Oftentimes you'll be asked, what is the domain of this function or of this relation? And I wanted to do some prep on it first. We have to back up a little bit, so we'll prepare. As I reveal things, you can write them down. Anything that's in blue or that's not already on your worksheet, go ahead and write as a way of taking notes. So the first thing we can talk about is a simple question like 2 plus 3, what's the answer? And of course the answer is 5. And if you just want to simply list things out or write an equation, you could say x equals 5. This is just 5. And if you want to plot it on a graph, then you could put it on the number line and 0, 1, 2, 3, 4, there's the answer, 5. A set is basically a collection. It's like a bag that you can put things in. And in this particular bag, in this particular collection, in this particular set, there's only one thing in it. There's only one element, and that's the number 5. And so that's what this would look like. Anytime you see these curly braces, that means set notation. This is a set, and it has one thing in it, 5. Very similar, if you have x plus 2 equals 7, and you're asked to solve, then you could say x is equal to 5, or just 5 is fine in some cases. So, and if you wanted to plot the graph, then it would look like this: 0, 1, 2, 3, 4, 5, and put the same dot. Same thing, set notation is here. There's another way of expressing answers, and it's called interval notation. It involves parentheses, and it actually doesn't apply yet. I'll talk about that in a second. Next question, what are all the ages of teenagers? This is actually, and we don't want to consider like 13 and a half or 15 and a half to be an answer. We just want to round to the nearest year. So there's actually a few answers to this. Collectively, all the ages would be all the numbers that have teen after it is 13, 14, 15, 16, 17, 18, and 19. There they are. And you can put them on you can graph them on a number line like this. It's visually where they are. If you wanted to talk about them in set notation, you can do it like this: 13, 14, 15. Now, all of a sudden, this set, this collection, this bag has 7 elements in it, 7 numbers. You could write them all out if you wanted to, or if you wanted a shorthand, you can kind of start the pattern off and then go ... and say when the pattern ends. Next question, what are all the even numbers? It's kind of tricky because we know what even numbers are, but to list them all out is, there's an infinite number of even numbers. It's not just these numbers here, it's the ones that come after it also. 2, 4, 6, 8, 10, 12, 14, 16, and so on, and also in the negative direction. So this is one way that people sometimes write it. You might also have seen the plinus or the plus or minus symbol, 0, plus or minus 2, plus or minus 4. That's another way to do it. If you want to graph it visually, this is where they're located on the number line, and you can see I've numbered them, I've labeled them. Every other tick mark is labeled. Now, you can take all of that and just write it in a set, and that would be what's called set notation. Again, we can see what the pattern is, and we understand, and we can extrapolate. Another way to do it would be to use what's called a rule, and you could say this. What are all the even numbers? Well, it's any number. If you take k as an integer, like the integers are 0, 1, plus or minus 1, plus or minus 2, plus or minus 3. All of those numbers are integers. And if you multiply them by 2, then you would get all of the even numbers. And the way this is actually written, if you're going to speak it out loud, you could say the set of all 2k such that k is any integer. That's how you verbally say it. This line means such that, and it separates the variable with like what you should do with the variable and the rule over here. What are all the positive real numbers? Here's one way that you could express that. You could say x is greater than or equal to 0. Oh, I should actually say this is wrong because I don't want to include 0. 0 is not a positive real number. So don't copy that down. Make sure you copy it with an x is greater than 0. Here, you can see that all these numbers get shaded on the number line. And actually, I don't want to include 0. So what I've mistakenly done is I've mistakenly put a solid dot right there, but actually it should be an open dot. Open dots refer to the idea where this is where the boundary is, but don't include the boundary. Solid dots, as I've mistakenly put here, say please include the boundary. 0 is part of my answer. So you can see you can take this whole thing and you can write it as a rule. pick any x. This is the set of all x such that should be greater than 0. And that just means, the answer is, I want to put in this set, I want to put in this bag all the numbers that satisfy this rule. X should be greater than 0. And so now we've come across something called interval notation, and now it starts to make sense here. It didn't really apply before with individual numbers or discrete numbers, but now that we have this continuous region over here of numbers, we might want to start thinking about interval notation. And one thing I want to say about that is that it uses parentheses. And it can be a little frustrating at first because we actually have lots of uses of the parentheses characters. Here they are. In English, you use parentheses one way. You can say, I didn't, but I tried, or something like that. You can see that parentheses are used in a specific way. And we're going to introduce a new way today of using parentheses. You might also in math know how to graph the point 1, 2. You go 1 over on the x-axis and 2 up on the y-axis. And this indicates an ordered pair of numbers you need to graph. Then, on top of that, in math, you could also use the parentheses to indicate change in order of operations. It's a grouping symbol. It's like, please make sure you do the addition first before you do anything else, and then do the exponent, and then do the multiplication. Then there's another way of using parentheses here with functions. Perhaps you learned about it at the very start of a chapter on functions. This is meant to indicate, this is not multiplication like it was before, but instead it's meant to indicate that the name of the function is f and the input is 2. And if you evaluate that, you're finding the output. What is the output if the input is 2 to the f function? So here we have yet another way of using set notation that I didn't even talk about yet, fifth way, in addition to these 4. And it's right here. This actually, this square bracket, because I made the mistake, over here, it really should be a parentheses. Parentheses 0, infinity. And if it really were greater than or equal to 0, then it should be, the bracket indicates that you are starting with a boundary. And these two things right here, this is not a set, this is not an ordered pair. This comma doesn't indicate that you have to graph the point 0, infinity. No. It means, this is set in interval notation, it means we're talking about the region that starts at 0 and ends at infinity. It actually has no end. It keeps on going. So the correct answer is parentheses 0, infinity, parentheses. And that indicates that the boundary line for this interval is at 0, but it actually doesn't include 0. If this were correct, then this would be the correct interval notation, including the boundary. All right. Let's see some more examples. What are all the legal voting ages? So if you're 18 or older, then you can vote. And you can see this is how you normally express it with an inequality, and this is how you graph it as a region, including the age of 18. Like if you absolutely turn 8 on the day you turn 18, yes, you're allowed to vote. So let's include that in our answer as for what are all the legal voting ages. And of course you can put it as a set notation like this, taking this and making it your rule in a set. And then 18, like it starts at 18 and goes up to infinity, including 18. What are all the illegal highway driving speeds? And the speed limit is 70 miles per hour. I had to look this up. There's actually a minimum. Like if you can't drive 5 miles an hour on a highway, you'll get a ticket. And actually, the question is, how slow is too slow, or where exactly? When will you get a ticket? And you'll get a ticket here, in all the different speeds that I've shaded. You won't get a ticket if you drive absolutely 40. This actually varies from like urban to rural, state to state. But for the purposes of this discussion, let's talk about like Pennsylvania highway driving. If you go 40, you're fine. If you go 70, you're fine. If you go anywhere in between, you're fine. But if you do anything outside of that, then you'll get a ticket for driving too slow down here or driving too fast up here. And that's how x is less than 40 or x is greater than 70 is how we express it here. And simply, if you wanted to import that into a rule, this would be the set notation. Here, the inner notation looks like this. We are going from negative infinity up to 40, and you're not including 40. And we typically just use parentheses with infinity because you can't really, it's not a clear boundary. we're not including a number negative infinity, but we have to not include it. So parentheses. And then the same thing over here to describe this boundary, this interval, sorry, this region, this continuous set of answers, 70, comma, infinity. We are starting at 70, going up to infinity. I'm not including 70, and no way we can include infinity. And then if we want to kind of unify them, consider them together, then you use this symbol right here. It's the cup symbol, and because it looks like a little cup, and it means union. It means take these two answers and put them together and consider them one answer. What are all the ages of teenagers? Now let's, same as before, except let's include the decimals. Let's say, you could say, let's pretend you're allowed to answer this question with, I'm 13 and a half, I'm 15 and a half, I am 15.25, I'm 15 and 6 months and 3 days. If you wanted to actually include all those answers, then what you get is all the ages between 13 and 20. If you're a 13-year-old, then we want to be able to say, yes, that's a teenager. And if you're anything less than a 20-year-old, then you're also a teenager. But as soon as you turn 20, then you're no longer a teenager. If you are 19 and 11 months and 29 days or 30 days and, if you're 19.999999 years old on the eve, a few seconds right before your birthday or right before the moment you were born, then you are not yet 20, and we want to still be able to shade that in. And any number less than 20 and greater than or equal to 13 should be shaded in. So that's how you express it simply. That's how you shade it. Notice the open dot, notice the closed dot, and you take that rule and you take that any compound inequality and you put it over here and make it your rule, and that's how you make it your set. Notice the simplest way to write this all of a sudden becomes bracket 13, comma 20, parentheses, the interval between 13 and 20, including 13. I mean, if you just wanted the smallest amount of handwriting for this particular kind of question, then it's over here on set notation. It becomes incredibly convenient if you have to do this over and over again, which you have to do in calculus. So it's good to represent that and understand how it's used. When did the United States of America have Republican presidents? And we're not rounding. So what that means is it'll look like this. We had Trump in these years, Bush Jr. these years, and Reagan and Bush in between these years. If you were to graph it, it might look like this. Graph it look like this. Graph it look like this. And you can see in between Bush and Bush Jr., that was Clinton. In between Bush Jr. and Trump, that was Obama. And after Trump, that's Biden. So you can see, and before Reagan, that was Carter. So these not highlighted parts are the Democratic presidents we've had, and there it is. And, I could write out more. This is basically more the same. I don't need more examples. I'm really including this because I wanted to show you can really stack these answers together if you need to. We're including all these years, so that's why we're using brackets. And we're using the union symbol, the cup character, over and over again, like 2 times to unify these 3 different continuous regions of answers, these 3 different intervals. Next question, what decimals round down to even numbers? So 1/2 rounds down to 0, 2.5 rounds down to 2, 4.5 rounds down to 4, and all the decimals in between. So all of a sudden it becomes, and actually this is only a partial list of all the inequalities that just keep on going forever and ever and ever. And it becomes incredibly difficult to kind of express your answer here because you have to produce an infinite list of inequalities. I guess you go ... downward. But on a number line, it would look like this. You can notice we're including 2 because 2 rounds down to 2. 2.5 rounds down to 2, but 3 does not round down to an even number. It stays at 3. 2.999999999 rounds down to 2. So we want to get as close as you want to 3 without actually getting to 3 to shade this interval. And notice that you can do this, and as soon as you establish a pattern, then you can go ... So this might be in terms of handwriting, this might be the shortest way of actually expressing the answer. Notice the parenthesis does not include 3, but the bracket does include the 2. So now that we've talked about different ways of expressing answers, let's actually ask the question, what is the domain? What is the collection of all the input values? And let's start off with a function. here that is graphically stated. These are not numbers. If the input is n, the output is q. If the input is n, the output is s. If the input is o, the output is r. The domain is the collection of all the input values. So you could if you really wanted to just write a simple list, you could go m, n, and o, and that is the domain. These letters are here in the domain. If the questioner is going to ask what's the range, then you could say QRS. But if you're graphing it, you could just like circle these and say, oh, that's the domain. You want to do it in set notation, put your answer over here into a set. Interval notation doesn't apply exactly just yet. So here, sometimes you can see that these brackets, these curly braces, actually do mean set notation, and so we've got 3 different ordered pairs. These are things you could plot. These are not intervals. These are things that you could plot on an xy coordinate axis. The point -7, 3, the point -2, 1, and so forth. Okay, so what is the domain? That would be all of the x values, -7, -2, -2, and 0. Notice you don't have to write -2 twice. You're going to plot them on a graph. They look here, and you could take this answer and put it into a set like that. Now, sometimes functions are defined graphically like this, or numerically like this, but sometimes they're defined in terms of a graph, and when I mean graph, I mean like an xy coordinate axis. So, what is the domain? The domain is the collection of all the input values, all the x values where the function exists. So if you're taking a look at all the different points, and just look only at the x values, you can see the lowest x value here is -2. The highest x value here, another answer incorrect. This should be 1. So -2 up to x is less than or equal to 1. -2 is less than or equal to x is less than or equal to 1. And so you can see, because these are both included, we have solid dots, and this actually should be on 1. Over here, you can take this answer and put it into a set, and that's how you get that. Again, this should be a 1. But of course, I want you to notice that over here in the interval notation is the simplest way to express this interval. You start at -2, you go up to what actually should be 1, and you want to include both of these. In terms of handwriting, interval notation is absolutely the easiest way to go. Sometimes functions are defined, or often they're defined like this, with a rule. If you want to know what the output is, take the input, square it, and multiply it by 3. That's the h function. And what is the domain? Well, actually, you can put any number you want into the domain, any number you want into the function, and get an output. Like any number you want, all real numbers will produce valid outputs in the range. You could take 0. 0 squared times 3 is 0. 1 squared times 3 is 3. -1 squared times 3 is also positive 3. So all real numbers work in this function. They all produce outputs, so therefore the domain is all real numbers. And actually, there's a lot of functions out there. Most functions that you see in a textbook have as their domain all real numbers. It's kind of it's good to remember. Most functions, and I'll come up with some exceptions down below. But most functions, unless they satisfy the exceptions down here, will just say that the domain is all real numbers, because you can put them all number in, any number you want in, and get a number out. There's a really funky symbol for that. This is a capital R. If you just write an R and you draw like an additional line kind of next to that one, then just so there's like 2 lines here. I don't know if you can see it. The line from the R, and then the line that you can draw in next to it, then that's what mathematicians just say. That's all real numbers. Very easy way to write this with handwriting. Interval notation, you go from -infinity to positive infinity, and you use parentheses whenever you're talking about infinities. Right. Moving right along, let's take this other function, the g function. And again, it's defined as a rule. The rule is whatever number you use as your input, you take the square root of it. You ask yourself what number times itself would give you the input. Like this. Like if the input is 9, then you ask yourself what number times itself is 9? Oh, the answer is 3. That's the output. If the input is 16, the output is 4. If the input is 100, the output is 10. But actually, with a square root function, you can't take the square root of a negative number. like what number times itself is -9? There's no real answer. There's no, like, neither 3 nor -3 times themselves give you -9. So actually, we need to make sure that -9 is not included in the domain. It has an input, -9 has no output. So only positive numbers are going to work in this, and that would look like this. What is the domain for this function? Well, it's x is greater than or equal to 0, because these are all the numbers you can take a square root of. If you don't believe me, if you're unsure of what I'm trying to say, then I'd recommend going ahead and ask your calculator. Type into a calculator the square root of -4, and if you make sure you use parentheses and all that, or if you communicate that well enough to your calculator, then it should give you an error message and say, I can't do this. So no output is given, so therefore we need to make sure we say that -4 and -9 are not included in the domain. And so if this was a simple way of writing it, this is the set notation way of writing it, and this is the interval notation. Notice, I think that this is, with the characters, is just fewer things to write here. You start at 0, you go up to infinity. Those are the boundaries. And we include 0, and we can't really ever get to infinity, so you use parentheses here. Same thing, same idea here. We want to make sure we take the square root of something like x plus 4. Well, whatever x plus 4 is, it's got to be greater than or that should be an or equal to 0. And this should be also greater than. So if you solve this inequality, then you get x is greater than or equal to -4. Again, these should have lines underneath. So all these numbers, when you add 4 to them, you can take their square roots. And it would look like this, very similar to the previous one. All right, so here's another example. You can't take a number and divide it by 0. Ask your calculator, it'll produce an error message. It'll say undefined or syntax error or something. So if I try and put 2 into this function, 2 minus 2 is 0, and I get 1 divided by 0, and I can't produce an answer. You can actually produce an output for any other number you want, just not the number 2. So what is the domain? Well, I have to make sure that x is not equal to 2. And if you were going to graph it, it looks very similar to all real numbers, except for it has this hole right here, this open dot. So less than 2 is fine, greater than 2 is fine, but just don't pick 2. And that's what we write here, the set of all numbers such that x is not equal to 2. In terms of interval notation, this hole actually breaks up the intervals into 2 different, continuous regions that you'd have to shade. This lower one down here from -infinity up to 2, not including 2, and make that take the union with that and 2 to infinity, also not including 2, and that's how you write that. For your reference, I've got all these ideas are associated with each other. When you don't want to include the boundary, use an open dot, use parentheses and set notation, use less than, use greater than symbols, and think about the sport basketball. Like there's a playing area, but as soon as you touch the boundary, which is like the colored part outside, like purple if you're Lakers or whatever, on the Lakers field court, then that's out, and so we're not including the boundary in terms of whether or not you're allowed to play in that area. But all these ideas are included. So closed dots on graphs, brackets on interval notation, less than or equal to symbols, greater than or equal to symbols, and I know in soccer and in field hockey, if you step on the line, if the ball bounces on the line, then you are still the ball is still in play, or you are still in play. The boundary is included in that. So there it is. Good job taking notes. I'd like to make sure you bring this piece of paper to class tomorrow, and just quick check to make sure that you wrote everything down. And I hope you use this, and I hope this prepares you for what we are doing in class tomorrow. So take care, and I'll see you in class.